Hello once again. In this video we're looking at nonlinear inequalities. This section basically, I wouldn't say it's so much difference than the section we've covered in inequalities. But I'll show you below the example of how the nonlinear inequality expressions look like. So whenever you see an equation which has these expressions, right, it's immediately you need to know that you are dealing with non-linear inequalities. So another way you could think of is that when speaking about inequality expression, which is this, right, we are also speaking about the comparison side, right? And there's generally three methods, I would say, for solving nonlinear inequalities. We have the graphical method, we have the table method, and we'll just call the calculations method, where you just calculate as you would normally. I want you to take note the effect of having the inequality expression, because for instance here we have the equality sign 5 equals 5. That holds true, and on the other hand we have 5 less than 5. This statement is not true, but do you notice that the equality expression has an impact on how we look at the expression? But however, on these three methods that we've stated here, the graphical, the table, and the calculations method, there's normally common rules. I would say they apply to all of them. The very first rule is that you may not multiply by an unknown variable where the sign is not known. What do I mean by that? Or let's say rather, why wouldn't we in this expression multiply by x? It's already stated in the rule that we may not multiply, but what's the reason, right? What effect does it have? So here we are doing just a quick example by just trying out and just inputting a value of 3 in this expression, and then we'll also put a value of -3 as x. So we want to see that whether does it have an impact if we multiply by an unknown sign of an unknown variable, because x here, if we agree, x can be both negative and positive. So we want to understand why we take this as a rule. Why wouldn't we multiply by an unknown variable? Or specifically in this example, why wouldn't we multiply by x on both sides? So on the first one, I'll just substitute 2, 3 squared minus 1 over 3 less than 5, all right? And then when we simplify this, we have 5.7 less than 5, right? Obviously this is not true, right? But let's see, on the other hand, if we substitute x equals -3, we'll have 2 minus 3 squared minus 1 over -3 less than 5. If we simplify this, we'll have -5.7 less than 5. This is obviously true, because this value is positive and this one is negative. Obviously, a positive 5 is greater than a negative 5.7. So do you see that we cannot just multiply by an unknown variable, because we don't know what that variable, we don't know the effect of that variable in this inequality expression. So that's the first rule: we shouldn't multiply by an unknown variable. And here was just a demonstration of why we cannot do that. The second rule, however, is that when solving nonlinear inequalities, we need to make sure we find the values of x for which the expression is 0, because at those 0 points, that's where the graph changes signs, right? What do I mean by that? Basically, this means we need to factorize. If you remember, factorizing x minus z1, x minus z2. So that's factorizing. So this rule basically says in order for us to be able to solve inequalities, we need to make sure that we do this as well when solving them. We need to factorize and solve for values of x for which this will be 0. All right. So we need to solve for this because it tells us that this is where the graph changes signs. In the next example, we will demonstrate what this means. Why should we factorize, and why should we find the values of x for which the graph is 0?